Welcome everyone to this webinar on getting started with MICROCHIP's MPLAB X software. This webinar is brought to you by DesignSpark from RS Components and MICROCHIP. I've just a quick announcement to make before we get started. Unfortunately, we won't be able to take live questions during the webinar, but instead we will have a questions and answers section at the end. If you do have any questions, please use the question box in your GoToWebinar console and we will try and answer as many of them as we can. Okay, let's get started with learning about MPLAB X software. I'm now going to hand over the controls to Giacomo from MICROCHIP, who is going to take you through today's presentation. Over to you, Giacomo.
Thank you, Simon. Good morning, everyone. With this short presentation, I would like to introduce you to the new MICROCHIP integrated development environment to develop embedded application with our solution. Today's agenda will show you a little bit about the MICROCHIP MCU development ecosystem, a little overview on the MPLAB X IDE itself, and then two main topics: that how to create, edit, and build a project, and then how to transitioning existing projects already made for the previous version of MPLAB, that is MPLAB version 8, to the new MPLAB X. And then we will take a look at some new features, only a few of them in MPLAB X. And at the end, you will see special offers that we can provide with this seminar through RS. So let's start with the ecosystem. As you can imagine, integrated development environment means that is a software platform that allows you to implement your embedded application from the beginning to the end. So that means in MPLAB X, it's a software program that you can download for free from our website, and having installed it on your PC, you can actually create your embedded project, and after creating the embedded project, you are able to organize your project using the project manager. You will be able to write your code inside MPLAB X using the built-in editor, that is a software editor, so is aware of all the structures and keywords of the several languages that you can use. And then there is the source level debuggers. That means you will be able to debug your code exactly in the file that you have written. So you don't need to have an external debugger in order to debug your code. MPLAB X itself is also able to managing and handling the programmer and debugger that you can connect to the PC via USB directly. So that means you will be able inside MPLAB X to not only simulate the execution of your code, but also to communicate with the microcontroller, having the microcontroller pre-programmed with the code that you have written and compiled inside MPLAB X, and then be able to make the in-circuit debugging. So you will be able from MPLAB X to execute instructions step by step, or even in running, monitoring the values of the variables that you have declared inside your code. And then there is a lot of plugins that can help you in order to add additional feature to MPLAB X itself. So with MPLAB X, you can write code in assembly, that is the native code of the microcontroller, but you can also use MPLAB XC compilers or third-party compilers if you want. You just need to install eventually the plugin to be able to use them. There are built-in inside MPLAB X the MPLAB X simulator. That is a built-in simulator that works at register level. So that means you will be able to simulate the execution of the code inside the core of the microcontroller. But you can also add third-party simulator like, for example, Proteus VSM from Lambda Center or other simulators, and so in that case you will be able to simulate your whole PCB and not only the microcontroller itself. Then, because MPLAB X is able to handle the USB programmer and debugger, you can use any one of our instrumented actually development tools like Picket3, ICD3, Realize, or even the starter kits, and be able to make in-circuit debugging on the microcontroller. But there are also additional third-party and legacy instruments that you can use with MPLAB X, just connected to MPLAB X via plugins. And talking about plugins, we are providing a lot of plugins directly. So for example, the data monitor control interface and other plugins for setting up our demo boards or for setting up some libraries. But there are also a lot of third-party plugins that can be added. For example, all the plugin, especially plugin for the editor that you can find for NetBeans, can also be installed on MPLAB X. And because the MPLAB X is an open IDE, you can download from one of our websites the SDK, the MPLAB X SDK, and you will be able to write your own plugin just using basically SDK with Java. So there is a plugin interface that is documented inside the SDK, and in that case, if you want to add a customized feature to MPLAB X via plugin, you can create your own plugin. Talking about compilers, MICROCHIP can offer C compilers, and we have three basically compilers, one for the 8-bit microcontroller, one for the 16-bit microcontroller, and one for the 32-bit microcontroller. All of them can be downloaded for free from our website, and the free version is not limited at all. You can do whatever you want with the free version. The only things that the free version doesn't do is the automatic optimization. If you want to enable compiler optimization, you may need to buy the standard or professional license. And in order to be able to make in-circuit debugging and to program the microcontroller for sure, you can use a programming debugger. In terms of microchip development tools, so we can provide Realize, ICD3, or Picket3 as an in-circuit debuggers. And the main difference between them can be seen immediately on this slide. So as you can see, the Picket3 is our entry-level in-circuit debugger, but even if it is the entry level, is capable to program and debug all our microcontroller from 8 to 32-bit microcontroller. And it's able to handle hardware breakpoints, so the breakpoints that are provided by the debugging feature of the microcontroller itself. And it's also the one that has the very useful function that is named program to go, so the possibility to download the firmware, the X file actually, the execution file on the Picket3 itself, and then you can detach the Picket3 from the PC, and just providing power to the Picket3, you will be able to program several boards just pressing a button that is on the Picket3 itself. If you want to have more speed and some additional feature like the ability to use software breakpoint and hardware stopwatch, you may need to use the ICD3 or to select the ICD3. In this case, also the debugging of the your application will be faster, because in this case the communication between the microcontroller and the PC will be faster because ICD3 is faster than Picket3. If you want to have a lot of debugging features, so the capability to make tracing of the code, capturing data while the microcontroller is running, be able to connect test points to the MPLAB X and be able to control those test points. In that case, you may have to choose the Realize. In this case, you have a lot of additional features that are not available on the ICD3. Those features are mainly intended for debugging purposes. Then, if you want to test our products, you don't need to actually create your own board from the beginning, you can easily select one of our evaluation and demonstration boards. We have a lot of them. For all our products there is one of them at least, or even more than one actually. There are some boards that are standalone boards, so you can only test the tools that, the product that is on board, and some boards that have plug-in modules where you can use that board as a motherboard to test different microcontrollers. So for example, with the Explorer 16, that is the development board for 16-bit microcontroller, just changing the plug-in module, that is a little piece of the board with the microcontroller on it, so just changing the plug-in module, you will be able to test with the same motherboard also the 32-bit microcontroller, and there are a lot of plug-in modules that you can use. And moreover, because the Explorer 16 is just a few buttons, LEDs, LCD, with the Pigtail and Pigtail Plus, you can even extend the functionality of the development tools. So, for example, you can add a graphics card to the Explorer 16, and then you can test the graphic solution that we can provide. You can add Ethernet board, and so in that case you will be able to create a web server on your PIC microcontroller. You can add the USB Pigtail, and then you will be able to read and write file, format and drive, and so on. There are a lot of more Pigtails that you can select. But if you want just to start with a very cheap system without any need to have to buy a programmer and debugger, you just want to test the functionality of our products, especially microcontroller, in that case you can decide to use starter kits. Starter kits are demo boards where the in-circuit debugger and programmer is on board. So those starter kits just need to be connected via USB to the PC, and MPLAB X will be able to program and debug code on those boards. Obviously, starter kits are fixed hardware. Some of them have some additional connector to expand their capabilities, but mainly starter kits are standalone devices, demo board, just to test the capability of the microcontroller that is on board with the hardware that is provided. For example, the PIC18 starter kit have the display, the SD card connector, and an accelerometer, so you can test this kind of hardware, but maybe you cannot test audio with that board if you don't want to connect and weld some wires on the board to have additional hardware on it. Okay, let's take a look at an overview of the MPLAB X IDE. The layout is basically the NetBeans layout, because MPLAB X is actually a NetBeans platform. For this reason, it can run on Windows, Linux, and Mac. And here in the layout, you can immediately recognize the main toolbar, where you will find the most frequently used function that you can select just pressing a button. And the project tab or project tree here, you can actually organize your project. Those folders are logical folders, so can be easily renamed, changed if they are needed. So you can actually structuring your project as you like. Then there is the File tab. The File tab, on the other hand, shows you exactly which are the files related to the project that you have selected, and moreover, the real position of those files on your hard drive. And then there is a Classes tab that is very useful, because in this case there is a list of all your types, labels, variables, function, and you can use this tab in order to navigate your project. That just double-clicking on the label will open the file that contains that label in the editor and bring the cursor where the label is declared. Then there is a very useful project dashboard tab where you have a collection of all the information about the project. So which microcontroller have you selected, which is the compiler and the version of the compiler you are using for that project, which is the checksum after compiling the project, how much RAM and flash are you using, which are the hardware resources that that microcontroller provides in order to debug it, so for example how many hardware breakpoints you have, and which is the tool that you have selected when you will try to debug or program the code. And then there is the navigator tab that is another useful navigation feature. In this case, is like the classes, shows you the labels and the identifier that you have declared, in this case not in the whole project, but in the file that you have selected in the project tab. The editor is actually a programming editor, so it's aware of keywords, make out indent, matching braces, and so on. It has its own editor toolbar, so a lot of useful buttons like comment, uncomment, increase indent, decrease indent. Bookmarks are already there as a button, so you don't need to go into a context menu. There is a glyph margin where there is the number of the line and any information that the live parser will give to you. And the arrow stripes that represent the tail length of the file, and here you will see some lines that are the messages that the editor gives you, and you can just click on the line and the file will be automatically scrolled where that message is on your file. And then there is the output window. The output window actually is the window where MPLAB X will provide you information about the results of the building of the project and what is happening on during the debugging section. So let's start with how to create, edit, and build a project with MPLAB X. A project in MPLAB X is actually a folder, just a simple folder. And if that folder is recognized by MPLAB X to be a project because it has a subfolder named NB project that contains the project setting files that are basically XML files. So you can even easily take a look at the project properties just looking at those XML files. The two folder build and dist will be created by MPLAB X the first time you build the project, and you will find in the build folder the intermediate files like the object file compiled by the compiler, and in the dist folder you will find the output file like the X file that will be the file that you will program on the microcontroller, and the alpha file that is the file that is used by MPLAB X in order to debug your application. So, as you can see on this slide, the title of the slide is Lab 1. At the end of the presentation, you will find a link where you can actually download a complete class on MPLAB X in which there will be the files in order to run these labs that I will show you today at your home. So if you want to have additional information and make some tests on MPLAB X, you will be able to run this lab by your own after this presentation, just downloading the class material from the link that will be provided. So the first one is how to create a standalone project. In MPLAB X, there is the New Project button. You can click there, or even go into the menu, File, New Project, or even with shortcut keys like Ctrl-Shift-N. In this case, clicking on the New Project, a wizard starts, and it will ask you which kind of project you want to create. So for example, if you want to create a standalone project, you have to select microchip embedded and then standalone project. Then clicking next and selecting the microcontroller. So for example, for Explorer 16, where you have by default the PIC24FJ 128GA010, you have to select that microcontroller and click next. That microcontroller actually have an optional debugger header that provides additional debugging feature to that microcontroller that is not available normally on that microcontroller. And if you are using a debugger header, you just need to let MPLAB X know about that in order to enable all the additional feature that the debugger header can provide to the microcontroller itself. Then you may need to select the tools, the hardware tools that you want to use to debug and program your part. For example, if you want to use a simulation, you can select a simulator if you want to use the simulation inside MPLAB X. And if you have Proteus VSM available on your PC, in that case, you can select Proteus VSM. In that case, you will be able to run the code inside the virtual representation or virtual model of the Explorer 16. In this case, selecting Proteus VSM, one of the last steps is to select which will be the compiler that you will use to compile the files, the source files in your project. So here, for example, for a PIC24, so that means for a 16-bit microcontroller, you can select assembly for the 16-bit microcontroller, that is ASM30. You can select the old microchip compiler like C30, or the new microchip compiler, that XC16. As you can see, you can have more than one compiler and version of that same compiler installed at the same time. Here you can just select which compiler and which version of that compiler you want to use. And then you can even change it afterwards during the development of your project, just go into the project properties and change the version of the compiler, or even the compiler if you want. Then it asks you to give a name to the project. And if you give a name, Lab1, and you give a project location, MTTTLS0999, in this case, the project folder, that means the folder that will be recognized by MPLAB X as a project, will be named lab1.x. The .x is not actually mandatory. It's just added by MPLAB X wizard because afterwards, if you are looking at that folder from Windows Explorer, in that case, there is no way to see in Windows Explorer if a folder is a normal folder or is an MPLAB X project. That .x in the name is just for you to remember that that folder is actually an MPLAB X project. Clicking on Finish, you will create an empty project. So if you have some files that you want to add, so for example, library file and so on, and source file that you have already written, you can just right-click on the folder in which you want to add the existing item, and then select the items. We strongly suggest when you are adding code to the project, source file to the project, to use relative path. You can actually select relative or absolute, but we suggest to use relative because if you are using relative path, you can easily move your project on your hard drive without losing the connection between the project itself and the file and the source file that belongs to that project. And then you can start to edit your file. As I said, the editor has a live parser that actually checks what you are typing while you are typing. So that means the errors, the possible errors will be immediately recognized and underlined in red, like the misspelled words in a word processor, and those parser error could be potentially compiling errors if you don't take a look at them. Sometimes they are not actually compiling errors, but only parser error. But it's a good best practice to take a look at every parser error to see if it is a real syntax error or not in your code. But this will help you in developing your code, because it will immediately recognize if you forget any semicolon or to close a parenthesis that you have previously opened. So it's very useful and reduce the number of building that you may need to do for sanity check. So basically the sanity check on your code is already done by the live parser. That saved a lot of time during the developing of the code. At the end, when you have finished with the code, you can just click on Debug Project, and the MPLAB X will take care to compile the project, open a communication with the development tools, program the microcontroller, and then run the code on the microcontroller. So everything is done automatically by MPLAB X, just clicking on Debug Project. And if you click on Program Project, in that case the code will be recompiled in release mode, and then the microcontroller will be programmed, and the master clear will be released in order to let the microcontroller run actually execute the code that you have just programmed. At the end, if you have selected as Protos VSM as a tool, as the development tool, the easiest window will show up, showing you the, let's say, the simulated version of the Explorer 16, and you will be able to see the result of the execution of the code. So in this case, the code that you will find inside the class material will just make tool LEDs blinking and having some strings display on the LCD. So now it's, you know how to create a standalone project, just selecting a target device, selecting the building and debugging tool, choosing the project directory, adding the files, and then build and run the code, in this case on a real target if you have the Explorer 16, or in the simulator if you use the demonstration version of Proteus with the DSN file you will find inside the class material. But, especially if you are already microchip customers, you may have a lot of projects already done in the old system. So that means in the previous version of MPLAB, MPLAB version 8. In this case, it's possible to port those code, or actually those projects, from MPLAB 8 to MPLAB X in a very easy way. First of all, the project that you want to move to MPLAB X should build in MPLAB 8. There is no way that if it doesn't compile in MPLAB 8, moving it to MPLAB X will magically compile. It has to compile in MPLAB 8 if you want to move it to MPLAB X. And the version of the project should be later than 8.14. So that means if you have a very old project made with MPLAB X 7.x or even earlier, you just need to open that very old project inside MPLAB version 8. In MPLAB version 8 there is an utility that automatically converts a whole project in the new format. And when you save again the workspace of that project, you are ready to convert that project from MPLAB 8 to MPLAB X. It's a very good practice to include all the files that are related to the project inside the project manager window of MPLAB 8, not just including the file via the include directives. And remember, MPLAB X is running on a Java virtual machine and can also run on Linux and Mac. That means, especially if you want to move a project from MPLAB version 7 or version 8 to MPLAB X because you want to move from Windows to Linux or from Windows to Mac, in that case be aware that in Linux and Mac the name of the file are case sensitive. So if you are not using in the include directives the proper name of the file, you may have that the project works perfectly under Windows, but as soon as you move that project under Linux, it will say that there is a lot of file not found because actually the name is not exactly the same. And also the backslash in the path of the file. The backslash in the path of the file is only acceptable in Windows system. On Linux and Mac, you have to use the forward slash and not the backslash in order to write a path to reach a file. And after the conversion, nothing happens to the MPLAB 8 project, so you will still be able to use the MPLAB 8 project. That means if you are running MPLAB X on Windows, you can actually have at the same time installed on the same machine MPLAB 8 and MPLAB X, and having the MPLAB 8 project and the converted MPLAB 8 project running under MPLAB X, sharing the same file. So you will be able actually to use the editor functionality of the MPLAB X and use MPLAB 8 to debugging and programming the part. This is a very useful feature, especially if you have an old tool that is no more supported in MPLAB X. For example, you have ICE 2000 or ICE 4000, or if you have ICD2s. ICD2s are not supported under MPLAB X, but you can use them, still use them under MPLAB 8. In this case, you can take advantage of the feature of MPLAB X and be able to use, still use MPLAB 8 to debug and program using the ICD2s. How to convert a project is very easy. For MPLAB X is a new project, so just click on New. And then instead of selecting a standalone project, you just need to select an existing MPLAB IDE version 8 project. In this case, the following page of the wizard will be a request of providing the MCP file of the MPLAB 8 project. If you provide it to the wizard and click Next, it will recognize which is the microcontroller inside the project from the information that are inside the MCP file, but you are still able to change it if you want to change it. But it will propose you the one that is inside the project, the MPLAB 8 project. Then click Next. It will ask you, because this information is not inside the MCP file, if you are using or not a header. And then another information that is not inside the MCP file, because it's usually inside the MCW file, is which tool you want to use. Here you can select, for example, Protos VSM, which is the compiler, especially the compiler version, because in MPLAB 8 you can only use one version at the time of a compiler. You can install several versions of a compiler even in MPLAB 8, but you are able to select only one, and otherwise you have always to change all the paths to the source file of the compiler itself. Here, no. Here you can select it just clicking on which one you want to use. And then clicking Next, you have to provide a name to this new project in MPLAB X. By default, the project location of the MPLAB X project will be the project folder of MPLAB 8. That means the MPLAB X project will be a subfolder of the MPLAB 8 project itself. Clicking next, it will be summarize what will be done during the conversion, and the main information that you can see here is, and it's also one of the main difference between MPLAB 8 and MPLAB X, is that in MPLAB 8 usually the debugging uses the COF file in order to debug the code, so the COF representation, the COF languages. In the MPLAB X, we use the ELF-DWARF format for debugging. That is the main information that is the main difference between the two. And then click on Finish. The project will be created. So just running the project, clicking on Debug Project, you will see inside the simulated version of the Explorer 16, or on the Explorer 16 if you have an Explorer 16, the application that is just it's a stopwatch that is running on the display. So after the conversion, and actually the conversion utility makes very easy to move an old MPLAB version 8 project to MPLAB X, and after the conversion you will be still able to use the MPLAB 8 if it's needed, for example for legacy tools. Okay, but that is to create and convert projects. Then there are some very useful features inside MPLAB X that will help you to save half an hour per day at least, a minimum of actually after half an hour per day using MPLAB X to develop your application instead of using MPLAB 8. And some of the features that enable this time saving are the navigation feature. In MPLAB X, the navigation feature is very, very powerful, so especially if you have a very big project, navigating them to go to where you have declared a variable, go to where you have declared a function inside MPLAB 8 could be potentially a nightmare. In MPLAB X, everything is made easy by some useful feature like the navigation window. For example, if you select a file into the project tab, immediately, without even open the file, you will see in the navigator window all the labels and the identifier that are declared in that file, and you can actually double click on one of them to open the file into the editor and to go where that label is declared inside the file. Another useful feature that is available inside MPLAB X is the possibility to create a statical graph of a function. So be able to have a graphical representation of the relationship between the functions. So you can actually see which functions are called from one function, and also, for example, in this case, you can see that the main call LCD init. Okay, but you can also do the reverse, and so which function are called by selected function. In this case, it will be possible to see which function are called by LCD init. So you can see which function call LCD init and which function are called by LCD init. And that is very useful. And just double clicking on the function box, you will go to the function. Double click on the arrow. In that case, you will go to where inside the LCD init the function, for example, LCD home is called. And then another useful feature is the hyperlink navigation. Just press and keep pressed the Control key on the keyboard, and every label became an hyperlink anchor to where that label is declared. So for example, if you keep Ctrl pressed and you move the mouse over a label, you will see a pop-up window showing how that label is declared. And then if you click with the left button of the mouse, you will jump where the label is actually declared, if it is a variable, or implemented if it is a function. So that is a very useful navigation feature. And then there is also a useful call stack window that allows you to understand which are the steps that the execution of the project, of the code, have done in order to reach a certain point. So for example, you can put a breakpoint inside the generate random dword function, and when that breakpoint is reached, you can open the call stack window and you will see how that point was reached. So here, for example, you see that that breakpoint was reached because the function generate random dword was called by the function stack init at line 113 inside the stack tsk file, tsk.c file, and the static init function was called by the main function at line 136 inside main.demo.c file. So it's very easy to find out which were the paths in the execution of the code to reach that breakpoint. And these are only few, let's say, additional feature that we have provided inside MPLAB X. There are a lot more features, and a lot of more can be also added via plugins to MPLAB X. Just for timing reason and to allow some answer and question time to this presentation, there is no time to present all of them. But you may find a description of those features on the MPLAB X IDE download page, where there is also possible to download a lot of additional manuals, user guides, and where you can find a lot of videos, a lot of webinars talking about the new feature that MPLAB X provides. There is a very useful developers help center that is the microchipwiki.com website, where actually you will find a lot of additional information, even for example how to find out which Java version have you installed on your PC, or some useful tips and tricks on how to speed up the compiling using, for example, parallel make option, and how to speed up the debugging. So, for example, enabling the keep control of the debugger, or some hints like avoid to have unresolved variables inside the watch window, because unresolved variables inside the watch window during the debug section will slow down the execution. So just removing those unreachable variables can speed up a lot the debugging speed of MPLAB X. The last link that you can see on this page is actually the link you can use in order to download the student files of the TLS 0999 transition to MPLAB X IDE MPLAB X IDE class, where you will find all the files and the step-by-step lab manual in order to be able to actually execute on your own machine the two labs that I have showed here in this presentation. So that means lab 1, how to create a standalone project, and Lab 2, how to convert an existing MPLAB X project. In that case, you will find for the first slide, inside the students folder, the source code that you have to add to a newly created project. And in Lab 2 folders, you will find the MPLAB 8 version of project, and so you will use that MPLAB 8 version project to convert it to the MPLAB X. So you will be able also to make some practice after this short presentation. And again, I would strongly suggest you to go to microchip.com/MPLABX and see all the other features that are available in MPLABX, and find out and maybe take a look at the webinars and videos that we have created to show how that new feature of MPLABX can help you to save your development time. And as I said, this is also the last slide of the presentation, it will be possible to order some tools with around 20% discount in the next 30 days from RS directly, and many of them are development tools, so basically you can have a 20% discount on the Picket free programmer, the ICD3 debugger and programmer, or the Realize, and even on the standard C compiler license. So if you want to buy the license with discount because you think that you want to use the compiler optimization to, let's say, for example, keep your source code as more ANSI C compliant as possible, in that case, you may need to have a optimized compiler in order to reduce the size of the code that will be needed on the flash automatic controller. In that case, you can also buy a license using this special code through RS. Okay, that is also my last slide. So I would like to thank you all for the attending this short web seminar, and I think that we can open the lines for questions.
Thank you, Giacomo. We've received a number of questions from the audience, so we'll try and get through as many of these questions as we can. The first question is, can I run a version of MPLAB 8 and MPLAB X at the same time on the same computer?
Yes, you can, and the reason is very simple. MPLAB 8 is a compiled Windows program, while MPLAB X is running on a Java virtual machine. So that means you can easily run the MPLAB X and MPLAB 8 on the same computer at the same time without any interference. The only things that you need to be aware is that the debugger tool that you have connected to the PC will use one driver, USB driver, and the USB drivers are different between MPLAB 8 and MPLAB X. That means if for that development tools you are using the MPLAB 8 USB driver, that tool will be visible from MPLAB 8 but not from MPLAB X. If you are using for that development tools the MPLAB X USB driver, that tool will be visible under MPLAB X and not visible on MPLAB 8. Also because only one of them can use at the same time the same tool. So you cannot use the same tool with both of them at the same time. That's the only reason. Okay, next question.
The next question is, does MPLAB X work on a Linux platform? Any particular version of Linux that it works with well?
I've tested it on Ubuntu, but it also works on every other distribution like Debian or Fedora. It's just to use let's say not a very old version. So for example, I've tested it on Ubuntu 10.4 version, I think. But it works also on the new one and also on Linux 64-bit platform is okay for MPLAB X. The Java version the Java runtime version that you have to install is actually starting from MPLAB X version 1.8. You can actually use the Gyrene 1.7. Before that version, so before version 1.7 of MPLAB X, is better to use Gyrene version 1.6, because at the end, especially for Linux users, the version of NetBeans on which MPLAB X is developed, because at the end MPLAB X is a NetBeans platform. The platform that was used to create MPLAB X is a NetBeans 6.9.1. So that is the reason why with previous version of MPLAB X, let's say previous than 1.8, that is the version that is at the moment on the website, it was preferred to use the Gyrene 1.6. But starting from 1.8, the suggested Gyrene version is 1.7.
Okay, great.
Okay, next question.
Next question is, let me just get this one here. Is there an option to combine boot code with application code using MPLAB X?
Absolutely yes, and it can be done with using one of the special folders inside. Sorry. There is a special folder in the project tab that is called loadables. In the loadables folder, you can load an X file, an object file, or even a complete project. That means you will have the project of the bootloader and the project of the application. In the project of the application, you can add as loadable the project of the bootloader. When you compile the application project, also the project of the bootloader will be compiled, and MPLAB X will create only one X file that will be the merge of the MPLAB of the bootloader project and the application project. So you will be able to have only one X file with the both bootloader and project or an application actually already in it. You can add to the loadable the whole project. In that case, it will be recompiled anytime you will recompile the application project. Or you can actually create your own bootloader project, and when it's fixed, just compile it and having the X file generated. And in the application project, you just need to add just the X file as a loadable file to the project. In that case, there will be a merge between the precompiled X file, the bootloader, with the application project that will be compiled when you click on compile. So it's really possible. The same you can do it for libraries. So if you are developing a library, you can have the library project as a loadable project for the application project that use the library. So in that case, you can easily debug all of them in source code in a very easy way.
Excellent. Okay. Another question here is there any limitation of compiler to optimize C code in the free version and the buy or the paid version?
Okay, the free version optimize a very little bit. That means only few optimization algorithms are there, so that mainly if you are declaring a variable and you don't use the variable, it will be probably removed, except if you declare it as a volatile variables. With the free version, there is no limitation in code, no limitation in memory. So that means you can actually develop your own application, and there is no commercial restriction. So that means you can develop your own application with the free version, and then you can sell it on the market without any worries about licensing and so on. So with the free version, you can do everything. The free version will just generate the code using basically ANSI C standard algorithm. That means the generated code will be bigger than the code you will generate if you are by the license and enabling the compiler optimization. So at the end, the compiler optimization are useful only if you need to reduce the code of the project, respect the one that you have when you compile the project with the free version. So no limitation, no commercial obligation using the free version, so it's free to use, free to compile, and also free to sell your project free to sell your product that you have developed using the free version. So no limitation at all. The only thing is that it will require more resources than the licensed versions. That means you may need to use a PIC with a little bit more flash than the flash that will be needed if you enable all the licensed optimization. So that's the only drawback of using the free version. You may need to use a bigger, maybe, microcontroller. So instead of using a 64K flash, you may need to use a 128, because you may have 70K of flash program and it cannot fit the 64. Maybe enabling all the optimization, if you have the license, you will have a reduction from 70K to 60K, and that is enough to stay inside the 64K flash part instead of using a 128K part. So at the end, the usage of the compiler is up to you, and actually is really depending on your application. But with the free version, you can do whatever you want.
Thank you, Giacomo. Unfortunately, we've run out of time. I would just like to thank everybody for attending, and just to let you know that a recording of this webinar will be posted on DesignSpark.com in the next few days. We hope to see you all on the next webinar in a few months' time, if you can check back onto DesignSpark for further details. Thanks, everybody. Goodbye.